All right, so moving on to the second example. I'm looking at the circuit, and I'm going to show you the process. So I'm going to do this kind of at regular speed, and I see that there's 6 resistors to be concerned with. So I'm going to start with my chart. I'm going to go with my V, I, and R, and I'm going to need 6 columns, or 6 rows, I should say. So 1, 2, 3, 4, 5, 6, and I also want a total. All right, so here's my chart. I'm now going to fill in all my information. That way I can determine what am I looking for and what do I have. So going through it systematically, the battery is providing 15 volts total. I know nothing else. R1, all I know is the resistance. Number 2, I just know the resistance. 3, I know the resistance. 4, I know the resistance. 5, I know the resistance. And same thing. And the reason I do it this way, this is really the hardest situation, because if I have the current at any given point, I can figure out the current for the whole circuit, so it makes it quite a bit easier. So this is actually the hardest. I'm giving you the examples of kind of the hardest ones you come across. So first step, I need to condense that pathway into one circuit, and I got to condense that one. So I'm going to do 2 at the same time here. So the diagram's kind of irrelevant at this point. So here's some of the details. So I'm not going to worry about the battery. Don't worry about that. So now I want to know what that becomes. I don't want to know what that becomes. So I know that's my 15 ohms. I know that's my 5. And again, remember this is in series. So RT would equal the 12 plus 8. So I would get 20 ohms in total here. On this one, total would be 6 plus 14. And it's also 20 ohms. All right. So now my second stage, so maybe I'll put this in green. So I condense those guys together for stage 1. Stage 2 then, I guess I'll do it in red. I'm going to condense these guys together. So making a little bit of space for myself down below. Here's my battery. Squiggles. And this one's going to become one pathway. So I have 15 ohms here. I have 5 ohms here. And this guy is going to become, because it's in parallel, I got to do 1 over a 20th. Oops, that's a 12th. A 20th plus a 20th. So that gives me 2 20ths. So RT, if you flip the fraction, I would have 10 ohms. There we go. So now I can figure out my total resistance. My total resistance for the circuit, RT, will equal the 15 plus 5 plus 10, which gives us 30 ohm resistance. So over here, I know the resistance for the entire circuit in my chart is 30 ohms. If you have 2 pieces of information, you can find the third. So 15 divided by 30, I'm going to have half an amp of current going through this particular circuit. Now I start picking off information. If I know my current is 0.5, that means everywhere that there is a single pathway, it will be 0.5 for the current. So going back to the original diagram, there's only one way through the first circuit, one way through the second, so all the electrons have to go through the first and second, which means the current through the first and the second resistors is half an amp. There has to be. Okay? So now I can find the voltage, or how many pretzels I had to eat, okay, to get through them. And for people that are watching this and aren't part of the class, when I refer to pretzels, a demonstration I did earlier in the unit, we compared voltage to pretzels, and we talked about how many pretzels you'd have to eat to get through each resistor. So that's why I keep referencing it back, if you're wondering why I keep talking about pretzels. So it's 7.5 there, and 2.5 there. So 7.5 and 2.5 means that we have consumed, or we've used up, 10 volts. All right. So if I get to this stage right here, so I got my X in my circuit, I had 15 when I left the battery. I have used 7.5 and 2.5. So that means that this X that I have marked here, I have 5 volts remaining. So to go down this pathway, I have 5 volts, and to go down this pathway, I have 5 volts. Now, what we would next go to is that I would have to go to my first drawing. All right, so I'm kind of working my way backwards. If I go to this drawing right here, see if I get to highlight, I start looking at my pathways. And when I combine those two pathways together, it was 20 and 20 ohms on either pathway. Because it's equivalent resistance, the electrons then would divide in terms of which pathway they would go down, they'd divide evenly. So I know the current is actually going to split in half at that point. So if the current splits in half on those two different pathways, I know that for each of these circuits, it's 0.25. And there we go. Everything's now known. So I have going through resistor 6. It would not be 6 because a quarter of 4 is not 6. Tough to believe. Good mental math there. Here we go. And a quarter of 8 would be 2. All right, so 3 and 4. And as I just, you guys are probably laughing at me, so stop that. This is why I need people around me to help with my corrections. A quarter of 12 is not 4, it's 3. There we go. Quarter of 8 is 2. So if I take a highlighter for a second, that's not a highlighter. Here we go. So if I look at that pathway, resistors 3 and 4, I had to use 5 volts. So 3 and 4, I used 5 volts. Finishing the math here, 1.5, hopefully I can do the math properly, and 3.5 there. So same reasoning. To go down this pathway, I still had to use 5 volts. So if I do the 1.5 plus 3.5, that also comes out to 5. My chart is absolutely filled, so I am finished. So, is this going to be easy? No. There's going to be some trial and error. There's going to be a lot of frustration, but we're doing it in class together, working as a team, as a group, and we'll work our way through. So the assigned homework, or what you're going to be working on, is, oops, that's not what I wanted to do. Here's the homework from the textbook. Number page 30 or 577. There's I think 6 or 7 questions to work through, and I might possibly shake up another hand and give you 2 or 3 more for the people that want a little bit extra practice. But you're going to find that once you get catching on to some of the tricks, it's actually going to go very quickly. All right, so we're going to leave it at that. Good luck. If you have any questions, and I know you will, I will be right over your shoulder, ready to give you a hand. Good luck.